Hi, it's Mr. Beck. We are going to do some right angle trigonometry review. This is the basics of trigonometry that you need to be successful in physics. We don't go much farther than this, hardly any farther than this in AP Physics. So this is the trigonometry that you need to know. What we're going to start with is a standard 3, 4, 5 right triangle. You know that this little symbol here represents the right angle, so we know that that's always going to be a 90-degree angle. And that's all we're worried about. We're not worried about, any acute triangles, anything weird like that. We just need a 90-degree right triangle. And you should recognize a 3, 4, 5 right triangle. It's pretty standard Pythagorean theorem, so this should be very familiar. 3, 4, 5 right triangle. It turns out that that angle is 36.9 degrees thereabouts. Okay, so let's start with this triangle. Now, what's interesting is we could make this triangle bigger. What if we made this triangle twice as big as it is now? Well, there's twice as big. The 4 becomes an 8, the 3 becomes a 6, the 5 becomes a 10. That angle stays the same. So I'm dealing with a similar triangle that's twice as big with exactly the same angle, which makes sense because I'm just scaling it up. I could scale it up even further. I could make it 3 times as big. Gosh, this triangle is 3 times as big. Instead of a 3, 4, 5, it's a 9, 12, 15 triangle. Why am I doing all this? Well, there's some interesting things here. As long as I've got a 36.9-degree angle, and I could scale it up to anything in between, much bigger, much smaller, I've got some interesting ratios that I could draw. Let me always pick this one that's far away and this one. Now, these have names, all three of these angles. Sorry, all three of these sides. Okay, so if I take a triangle, and I've got an angle I'm interested in, this one over here is always going to be opposite that angle. This is always going to be called the hypotenuse, the one that does not touch the 90-degree angle, hypotenuse. So it's not touching that right angle. And then this is going to be adjacent. Know that if I had picked this other angle up top here, then this one would be the opposite and this one would be the adjacent. So the opposite and adjacent are relative to that angle. The opposite is the side that is not making up the angle. So these two sides, the hypotenuse and the adjacent, make up the angle. The opposite is that far side. And so let me do a ratio. Let me say, I don't know, this far side versus the hypotenuse, the opposite over the hypotenuse. Well, in this case, it's going to be 3 divided by 5. If I do 3 divided by 5, that's going to be 0.6. That's interesting. So that's my opposite over my adjacent, my opposite over my hypotenuse. Now, let's take a look at this next triangle. Here, if I take the ratio of that opposite to this hypotenuse, I've got that opposite over the hypotenuse, giving me 6 over 10. And what does that calculate to? Let me just plug that into my calculator. Oh gosh, that's also 0.6. Isn't that funny? 0.6. Okay, here's the 3 times the size triangle. Let's see, I've got 9 and 15 as my opposite and my hypotenuse. So if I take that opposite over my hypotenuse, I'm going to get 9 divided by 15. Now let's see, what's 9 divided by 15? Oh my gosh, that's also 0.6. You know, if I took this triangle and made it any bigger or any smaller, it will always have, as long as I got that 36.9-degree angle, that ratio of the opposite to the hypotenuse is always going to be 0.6 for this particular triangle. Well, does that work with the other relationships? Well, let's take this. And now I've got a 4 as my adjacent and a 5 as my hypotenuse. So let me do my adjacent and my hypotenuse. If I take those, then my adjacent is 4, my hypotenuse is 5, and 4 divided by 5 gives me, let's see, oh, it's 0.8. Okay, what about this one? I've got 8 divided by 10 for my for my adjacent over my hypotenuse. It's going to be 8 over 10. And 8 over 10 gives me, let's see, oh, gosh, that's 0.8. Here I've got 12 and 15 for my adjacent and hypotenuse. So if I take my adjacent and I divide it by my hypotenuse, it gives me 12 over 15. And if I calculate 12 over 15, Oh my gosh, that's also 0.8. It works here as well. This ratio of the adjacent to hypotenuse, as long as I've got a 36-degree angle, 36.9 degrees, is going to give me 0.8. Well, I got two other things I can compare. I can compare this opposite to this adjacent. So let's say opposite over adjacent. If I do opposite over adjacent, here it's 3 divided by 4, and that gives me, oh, that's 0.75. For this triangle, I've got opposite of 6 divided by adjacent of 8. So that's opposite over adjacent. And so that's going to be 6 over 8. And 6 over 8 is, oh my gosh, that's also 0.75. For this third one, I've got opposite of 9 and adjacent of 12. So let's say if I do opposite over the adjacent, that's going to be 9 divided by 12. And that's going to be, oh my gosh, that's also 0.75. And so it's almost like I could store these values, 0.6, 0.8, and 0.75 are relevant if I've got a 36.9 degree angle. And ancient mathematicians realized, hey, this is something interesting, it's neat, it's always that ratio is good. So for a 36.9 degree angle, I've got these three ratios. Let me call this one of opposite over hypotenuse. Let me call that the sine of the angle. And that symbol is called a theta. And that's what we usually use in physics. We use that for the angle. So the sine of the angle is the opposite over the hypotenuse. And then adjacent over hypotenuse, let's call that the cosine of the angle. And then the opposite over the adjacent, let's call that the tangent of the angle. And so imagine you're an ancient Greek and you're working with triangles and you're making the measurements and you're getting the ratios. And so all you do is you start with a 1 degree angle, triangle with a 1 degree angle, and you write down those numbers. And then you get a 2 degree angle and you write down those numbers. You get a 3 degree angle, you write down those ratios. And so you could calculate, you could build an entire table of every single possible angle and then what those ratios are in terms of sine and cosine and tangent, and list all of the angles here, and you would have those numbers and they were going to be good to go. Every time you have that angle, you know that ratio. That's all it is. And so we abbreviate. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. We have a mnemonic, something that we like to say when we have those ratios. And what we like to say is SOHCAHTOA. And so this merely says that the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. That's how you remember SOHCAHTOA. That's how you remember those relationships. So SOH means that the sine is the opposite over the hypotenuse. CAH tells you that the cosine is the adjacent over the hypotenuse. And TOA is that the tangent is the opposite over the adjacent. Now, it sometimes becomes handy to multiply through. And so if you multiply here, sine theta is opposite over hypotenuse, multiply by hypotenuse, and you get that the opposite is the hypotenuse times the sine of theta. The adjacent is the hypotenuse times the cosine of theta, and the opposite is the adjacent times the tan of theta. So you just need to be able to use some simple math to get through there. And so that is the basics of SOHCAHTOA and right angle trigonometry. So that's a definition of sine, cosine, and tangent. And this is if you have the angle, you can calculate. If you know the angle and you can calculate the sine of the angle, then the ratios, the opposite and the hypotenuse, you can use to figure out the other sides that you're missing. So how do you do trig on your calculator? It's easy if you have the angle already, because you should know that if I have the angle already, what I need to do is just, if I wanted to get the sine of, 37 degrees, well, first of all, you have to make sure your calculator is in degrees. If your calculator is in radians or gradians, it's not going to work. So the first thing is you need your calculator in degrees. So calculator in degrees, make sure. Now, how do you do that? There are buttons on your calculator that will allow you to change the mode. So here you've got a mode button. Here you've got a mode button. Those mode buttons will, once you'll go through the menus, but you just have to make sure that you select the mode and you find to set it for degrees. If you're having trouble with that, see me with your calculator and I'll help you set the mode. So you must first have your calculator in degrees. Once you're good with that, if you wanted the sine of 37 degrees, you would simply type sine and then 37 degrees, 37, and you'd hit enter and it would give you your answer, okay? So, or equals in this case here, enter. So sine 37 degrees is easy. So that's how you would get to that answer. That's pretty easy. But if you knew that the sine of the angle that you didn't know happened to be, 0.157, if this was what you're trying to solve for, well, how do you enter in sine theta equals 0.157? How do you solve for theta here? Well, if you were doing other math and you had like, x times y equals 0.157, well, if you were trying to solve for y, what you'd do is you'd divide both sides by x. And so in this case, y would equal, you could say it's 1 over x times 0.157. And if you remember some of your math, you know that 1 over x is the same thing as x to the negative 1. So I could say that y equals x to the negative 1 times 0.157. Okay? Why am I giving you that? Well, what if you tried the same thing with this sine theta equals 0.157? Couldn't you, in order to solve for theta, divide by sine? I know this doesn't make any sense, but just go with me for a second. Well, then sine would cancel out over here, right? Just like the x would cancel out over here. And then I get theta equals 0.157 over sine. Well, wouldn't that also be 1 over sine times 0.157? And so that would tell me that theta equals sine to the negative 1 of 0.157. Guess what? On your calculator, there's a sine to the negative 1 button. So let's take a look at that. Let's look at two of my famous scientific calculators. One of them right here has this button up here that's got a sine to the negative 1. And it's above the sine. Here on this calculator, above sine, also we have sine to the negative 1. And so to get up there, on this calculator, you hit second sine to get up to sine to the negative 1. Here, you'd have to hit shift sine in order to get up to sine to the negative 1. So what I'm really doing is if I want that angle, I have to sine to the negative 1 the number that I'm looking at, the 0.157. So on this calculator, I would do shift sine to get up to sine to the negative 1, and then type in 0.157, hit equals, and I'm going to get my answer. Same thing on this calculator. I'm going to do second sine to get up to sine to the negative 1, and then 0.157, enter, and I'm going to get myself the answer. So that's how you do these trig on your calculator. And so I've also got an inverse cosine and an inverse tangent. So if you're ever trying to solve for the angle, it's a simple method of doing the shift sine, shift cosine, shift tangent. So that's how you use your calculator to do trigonometry.